Hey everybody and welcome back. In previous videos I've showed you how to deploy CrowdSec onto Docker, but today I'm going to show you how to do that in Kubernetes, and thankfully it's not too complicated. We've already got many of the prerequisites in place. So as a quick whistle-stop tour, CrowdSec sits on your traffic proxy, and it inspects all of the traffic that flows through that proxy against its known host of bad IPs and bad threat actors and signatures, etc. So the beauty of having this is that if you have your firewall already inspecting your traffic, you've got another layer of security. And this feeds nicely into a web GUI, and you can even host a local dashboard to keep tabs of what's happening on your proxy. Furthermore, you can also set up monitoring and alerting, and I've left this in this video so that if you spin up something like Gotify, you'll be able to plug that in and get real-time notifications and alerts onto your mobile device or through your web browser. So let's dive straight into this. I'm going to walk you through the configuration files. We're then going to set up and deploy each one within Kubernetes, and then hopefully by the end of this we'll be able to validate it both locally, and we'll be able to do some bans and some unbans, and then we can see this also within the web GUI. Okay, so to get this working, we're going to be going through the official documentation with just a few tweaks that I've added to make this work on a local Kubernetes install. Now this should work on both K3S and RKE2, so it doesn't matter which you're using. So if we look through the documentation, the most important bit is halfway down. We're not going to spin up the initial kind cluster. We've already got a working cluster. We're not going to use the test application because if you've been following my videos, you've already got things like traffic up and running. You've also got things like Pi-hole and maybe a few other things by now, because I showed you how to move Docker Compose files into Kubernetes manifest and Helm deployments. So skipping on from that, we get into the actual bit we need. So if we look here, we need to install Cert Manager. Now we've already installed Cert Manager because we needed it for Rancher. And crucially, we've already set install CRDs true, because if you check one of my scripts previously, it automatically applies the YAML file for CRDs. Those are custom resource definitions. That allows us to define our own custom resources. So if you haven't got this, or you haven't done Rancher and you want this on a bare machine, make sure that you do follow this exact command here. I'm going to skip this in my video and move on to the next part. So next we need to install Reflector. Now, what's Reflector? Well, it reflects secrets into other namespaces. And I've showed you before that namespaces are important, and they're a way of segmenting our cluster. So I work on a one app per namespace basis. And in this instance, we're going to be using Cert Manager for some of our certificates, and we need to make sure that those are available in different namespaces, mainly traffic and CrowdSec. So Reflector is going to enable that. And when we come onto the deployment, we can actually specify which namespaces we want certain certificates to be shared with. And like I've just told you, we want to be able to share certain certificates between both CrowdSec and traffic. That's going to be important for the bouncer. And if you remember from my previous CrowdSec Docker video, the bouncer is much like the bouncer at the nightclub. That's the piece of software that either allows traffic through or it bans it. So the first thing we're going to need to do is to modify our ingress for traffic. And if we scroll down here, the key thing really, and I will go through this in detail, is the additional arguments, because this is where we specify the bouncer version, etc. And we set which entry points we want this bouncer to operate. So here it's Web 80 and Web Secure 443. After that, because this is the configuration for traffic, we're going to have to redeploy traffic. And then we're going to get onto installing CrowdSec. Now, here's the values.yaml for CrowdSec, and if you've been watching my videos, you'll know that a values.yaml file means we're going to be doing a Helm install. So I'll talk through all of this in detail in a moment, but then we're going to deploy CrowdSec, and then once we've done that, we're pretty much ready to go. We don't even need to register the bouncer because it takes care of all of this with the Reflector and the TLS keys. Awesome. Okay, so let's jump into the code. Now, as I mentioned, if you haven't installed Cert Manager, go and do that. But assuming you've now done that, let's have a look at CrowdSec itself in detail. Now CrowdSec is going to be deployed using Helm, And here's the values.yaml that's taken from the official documentation and tweaked slightly. Now the first bit here for profiles and the notifications, this is just for setting up Gotify for notifications. Now you can choose to delete this if you don't want to use Gotify, but I recommend you do use Gotify because then you'll be alerted when CrowdSec is actually blocking something. So go ahead and deploy that. You can follow my previous video about how to move a Docker Compose file over to Kubernetes, and I'll probably share the Kubernetes files anyway after this video. So let's skip past this part because it's optional. And here you can see the remainder of the CrowdSec YAML. So what we need to do is firstly in the TLS section, so this is going to be for the certificates. We want to have a reflector. So remember we set that up for the bouncer and the namespace is traffic. So this is going to allow CrowdSec to have access to the traffic certificates in order to work. Next, we're going to get onto the agent. So if you remember, CrowdSec is basically an agent and an API in its most simple guise. In here, we're going to set some tolerations so that it doesn't apply onto the control plane, our master nodes. And then we're going to set some acquisitions. So this is basically where is it going to acquire the logs from. And we do that by specifying the pod name of traffic and then putting a wildcard. Now that's because all of our traffic pods are named traffic dash and then some randomly generated string. So this means it's going to acquire the logs from any traffic pod that we've got. And in my previous video, we spun up 2 replicas. So it will have access to both of those. So no matter which traffic pod your traffic is going to be routed through, CrowdSec will be able to read that and pass it to the bouncer. After that is where you can specify some environment variables. Now, I've just put a couple in here. I've added the whitelists and I've added traffic, Linux, Home Assistant, Authelia, Vault Warden, and Unify. And typically these enhance the default setup. They are optional and you can go on their website, you can go onto the store and find all of the different applications that it supports. Effectively, what this will do is have signatures or workflows or attack patterns that are perhaps specific to those applications. So there may be certain ways in which Home Assistant is attacked that Authelia isn't. So it will have those specific nuances built into it. It may also have different tolerances. So you might have a different tolerance to a brute force attack on Home Assistant as compared to Vault Warden. Next is the persistent storage. I've set that to false because we don't actually need it to have any persistence. It can just run in memory. It doesn't need to write anything to the disk. You can do that if you want to retain logs for a long period of time, and you would set that to true, and then in my instance go into Longhorn, and much like in previous videos, we'd create a volume and then we create a persistent volume claim within that namespace. I've set the node selector to be our worker node, and in my setup my worker nodes have additional resources to handle the extra workload of additional pods. The next bit is the image pull policy, so I've set it to always pull, so anytime I restart these pods it should go and grab the latest image. Not always best practice, certainly not in a production environment, but for a home lab I think it bridges that divide between convenience and security. Next up we've got the LAPI, so this is the local API. So on here, I've not enabled the dashboard, but you can go and enable the dashboard if you want. I prefer to use the Web GUI one, which is hosted by CrowdSec themselves. Don't worry about privacy too much. Yes, they'll know your IP address, and yes, they'll know some of the traffic attacks that come through, but there's no worry about data privacy because they're not actually retaining any of the data that was sent. It's more just the IP and the types of attack that were launched against you. Now again, we've got the option for a persistent volume with the API. Now, I'm going to set this to false as well because I don't want it to save any data. I'm happy with real-time alerts that I can act upon. So next up are the resources. And it's set a limit of 200 megabytes for the RAM. And it's requesting a quarter of a CPU and is requesting 200 megabytes of memory. So as is good practice with all pods, you want to specify these limits and thresholds because this helps assign it to a node. Now, I've got parity in my nodes, they're all exactly the same, my worker ones, so this doesn't actually make too much difference, but it's really important to understand what resources are and how you use them, especially in a production environment. Next up, we've got the environment variables for the LAPI itself. So I'm not putting the API on. Here in your enroll key, you need to go and grab your CrowdSec online API key so that you can see it on their website. That's only if you want to use that. You don't have to. It will work without it, but I like to use it. So when I run this, I'm going to put my key in here. Next, you want to give it a cluster name. So I'll probably just call this my RKE2. And then you want to give it a tag of home lab. That's just because you could have multiple clusters and multiple different tags you want to assign to each cluster. After we've done that, we're going to again assign this to be on the worker node and always pull a new image when I restart it. So that's it. Once that's configured, you should be able to run the Helm install for CrowdSec. For the reflector, again, this is going to be a Helm install, really straightforward, and I've just said to put it on the worker nodes again. Nothing different there. The next one is a bit more interesting, and this is traffic. So within traffic, we've modified this somewhat. So the top part for the global arguments is fine, we haven't changed that, but the additional arguments have changed. So in here, you'll notice these lines here. So the first one is to add plugins. So you can actually spin this up and do it on deployment as opposed to having to deploy this as a separate container like we did within Docker. So all this is saying is we're going to have a module name, and this is the same bouncer we used within Docker. We've set it to version 1.116. You will have to update this over time. We've created a middleware for the web, so port 80. We've created a middleware for Web Secure 443, and then we've set it to use the bouncer, basically. And we've set the provider to be the Kubernetes custom resource definition. The next part for deployment hasn't changed. The node selector hasn't changed. The ports are the same. The ingress is the same. The providers are the same. RBAC's the same. The service is the same apart from this crucial line here, the external traffic policy. Now this is really important and slightly complex. So by default, the external traffic policy will be cluster. Now we're using kubevip to do our load balancing, and this premise is the same if you're using something like MetalLB. Now if you use a cluster here, what's actually happening is, because of high availability, your traffic isn't going directly to the service. Instead, because we want high availability, it basically creates almost a floating IP, a bit like that virtual IP where traffic will go to, and then it will be load balanced across the various kubevip nodes and ultimately end up on a service. Now, that's simplified. Do go and read up on the documentation if you're interested. But because it's routed through Kubernetes and load balanced, it loses the source IP. Now that's really problematic for CrowdSec because it wants to know where the source has come from so it can put the bans in place. If you don't do this, you're going to get internal IP addresses at best, and most likely it just won't work. You'll also need to set it to local for things like Pi-hole if you want to be able to see where traffic originated, because otherwise it doesn't know the source IP. So by setting this to local, you're going to see the local IP. Now to do that, you'll have noticed that in my previous script I've updated it so that kubevip is now spread across every node within our cluster. That's a bit overkill. It could actually just be restricted to the worker nodes additional to the master nodes. That's because in order to use local, you need to have kubevip bound to the same service node as the service, i.e. traffic or Pi-hole. That's because instead of being routed through that additional middleware layer, it's now exposing it directly to the node, a little bit like a node port, but it's not a node port. So to use local, you need to have kubevip or MetalLB installed on each of the nodes where you have the service. Next, we're going to enable some logging so we can see the logs, and that'll be useful for when we're doing bans and seeing the real-time traffic. Experimental plugins are enabled because if we scroll back up to the top, we'll see that this is an experimental plugin. Now, we're going to mount a volume because we need to mount the secret, and that's where we did that custom resource definition and, importantly, the reflector. So it's going to mount the secret from Cert Manager into the pod. And again, I've just put traffic to always pull, so when I restart it, it's going to redeploy it. Okay, so that's all we need to change. So let's go ahead and deploy this now. One last thing before we do that, do note that these files might change over time. So if it doesn't look exactly like it does on screen, that's probably because something's changed. But the process should still be the same, and hopefully the walkthrough of the variables is still applicable. But always consult my GitHub for the latest files, and I promise to try and keep this compatible. Okay, so if you've been following my videos, you probably have a setup that looks something like this. So in the home directory, we've got our manifests and our home folders. And in the helm, I've now added CrowdSec and Reflector and updated the traffic file. So let's hop into our terminal and then we should be able to start the deployment process. So the first thing we're going to want to do is to install Reflector by EmberStack. So to do that, we need to add the namespace first and then run the install command. So whilst we're at it, we're going to do the CrowdSec Helm chart, and then we're also going to do the EmberStack one. Now I got a warning there, and that's because surreptitiously I slipped this into one of the scripts previously because I knew we were going to do this later on in the journey. But if you haven't got it, do make sure that you add it. I also need to go back and fix the permissions on my kubeconfig file, which I still haven't done, but I will do in a later script. Next is to add the actual EmberStack. So here we add the EmberStack one and we hit return. And then we can do a Helm repo update. Helm repo update. And that's going to update the repository so it knows what it means when we say spin up install CrowdSec. So now that's complete, we can actually go and install Reflector. So to do that, it's really straightforward. We're going to do a Helm install. It's going to be called Reflector, and it's from the EmberStack Reflector repository. We're going to create a namespace for this, and it's going to be called Reflector. So let's run that command. Now that's going off, and you can see here that it's status deployed revision 1. Excellent. So the next part is to deploy traffic. And to do that, we need to follow the previous command, but make sure that we specify the values.yaml file. So to upgrade traffic, we need to run the following command: a Helm upgrade, traffic name, traffic repository in the traffic namespace, and we're specifying the new values YAML file that should be the same as the previous one. So when we run this, that will go away now and upgrade our traffic deployment. So you can see that it's deployed. It's the second revision because we've deployed it again over the first revision, and there haven't been any errors with that, so it's successfully deployed. Perfect. Let's get on to the next step. So the next step is to install CrowdSec itself. So that's a Helm install, the first time we've installed it. CrowdSec, the name from the CrowdSec repository. We're going to create the namespace CrowdSec, and then we're going to specify the values.yaml file. Now again, I've updated this with my values. You'll need to do the same for this if you want to use the web interface. So running that, it's going to go away, it's going to pull that, and then hopefully spin up what we need. So there you can see it's actually created it, deployed, revision 1, and it's created the first login credentials for using this. So let's clear that and then just double check how that's going. We're going to run a kube control in the namespace of CrowdSec, and we're going to get all the pods. So running that, you can see that we've got the L API, the local API, that's up and running, and we're waiting for the 2 agents. Now the local API will always deploy first, and the agents are sat there waiting. There's a clue to that. Let's get on to it. And the clue is we haven't installed the bouncer. That's because we need to create a new middleware for that bouncer. So let's go and do that now. Now the bouncer looks like this, and it's very similar to if you cast your mind back to Docker. So it's basically just configuring the middleware. So the bouncer is a middleware, and it's the bit that sits between the client and the end service. In terms of traffic, it's going to send that traffic to the bouncer. The bouncer applies its rules and denotes whether it can be accepted traffic or denied. So it's going to listen for port 8080. You'll have seen that in the previous video. And it's also going to use these keys. Now the beauty of this is, because it's using Cert Manager, we don't need to do the registration that you do with Docker, i.e. generate that API key and then save it within the bouncer. We can do that here just by using keys. So we're going to deploy this with kube control. So stick this onto your host, doesn't matter where you put it. I'd like to put it in my manifest folder because it's a manifest, and then we're going to run the following command in our terminal. So here you can see I've added the middleware in the manifest/bouncer, and then in the terminal we're going to go to there and apply it. So we can do kube ctl apply -f, and then it's going to be in the manifest/bouncer folder, and then it's going to be called bouncer middleware.yaml. So with any luck, when we run this, those pods previously, i.e. above the agents, should come out of that pending state. So now that's being created, and hopefully now if we go back up and we look at the pods, those should be up and running. So now running the command again, yes, you can see that they're up and running and they're ready. So fingers crossed, CrowdSec is up and running. I'm going to hop now into Rancher just because it's got a friendly logs and CLI and just validate that everything's working. Let's go. So over in Rancher, yours will look something similar to this if you've been following my videos. Let's go over to the workloads and click on the deployments. And here you can see the LAPI, traffic and reflector, and everything's green and healthy. That's good. So now let's hop into our pods and see all the respective pods that we set up for CrowdSec. So we've got the LAPI, the local API. Let's have a look at the logs. Yep, perfect. All that looks good. It's got traffic flowing through it. And if we select one of the agents, it looks like this. It's pulled down everything we asked for, all the configurations, all those additional community ones, and it's up and running and starting to process data. Excellent. Now, as I mentioned on the screen message earlier, I haven't quite got this working perfectly with RKE2, but it does work perfectly with K3S. So what are the issues? Well, it stems back to where we set the external traffic policy to local. On K3S, that's absolutely fine, there's no issues. But I think with RKE2, the issue is that the security policies that are applied to RKE2, so things like the CIS 1.6 benchmark, that's doing something funny behind the scenes, I think with some of the IP tables, etc. So there's a bit more work I need to do, and if any of you guys out there know how to fix this, it would be greatly appreciated if you could share that. But it will sort of work in a way, and I'll show you that in a minute. So if I hop over to the Pi-hole that's hosted now on this RKE2 cluster, and if I go to the query log, you'll see the issue here. It's saying that all traffic is coming from 10.42.0.0. Now that's not very useful because it's hiding the source IP. And as we know, CrowdSec likes to know the source IP because it can block known bad actors. Now this is still going to provide protection against attacks, but the problem is all traffic to the proxy is having this IP address. So if ever anyone is blocked, it will block this IP and it will block all your local access to the network. We can actually demonstrate this by going back into the pod and putting a ban in place within CrowdSec, and then I'll refresh this page and show you what I mean. So back here in Rancher, if we go to the LAPI and we execute the shell, if I do a CS CLI decisions add-i for the IP address, and if I put 10.42.0.0 and hit return, you can see that that decision has been successfully added. Now if I go back to Pi-hole and hit the refresh, or just reload this page, you can see that we've been denied. So whilst it is technically working, the problem is it's going to ban your local access as well, and we don't want that. So I'm going to keep working on this in the background, so do keep an eye on whether I update the GitHub configuration, because as soon as I have that I will let you know. But up to this point, all the process has been exactly the same for both K3S and RKE2. So I'm going to hop now into my K3S test cluster that I have spun up, and I'm going to show you the external traffic policy set to local, and then I'm going to show you the same applications that are working, and you'll also see the source IP. So here we are over on a K3S cluster that's been up for a while now, and if we go to the pods, we'll see that we've got CrowdSec up and running. Now you can see CrowdSec here, the two agents and the LAPI. Now importantly, if we head over to services and then go down to traffic, once we click into that we see that we've got the two pods running for traffic, and if I edit the YAML for this traffic service, here you'll see that I've actually got the external traffic policy set to local, and I've also got the service set to local for Pi-hole. So let's log into the Pi-hole that's hosted on this K3S cluster, and I'll show you the difference. So here on my normal Pi-hole.gyms garage that I've got on K3S at the moment, you can see that all my network is using this as its DNS resolver. And now importantly, if I go to the query log, you'll see here that it's getting local IP addresses from local machines, which is great. So my IP on the current machine that I'm recording this video on is on VLAN 7 and the IP address is 100. So I'm going to ban IP address 7100, and then hopefully this page shouldn't be available to me, but is available to everyone else on the network. And this will be the same thing as when it's seeing external IPs coming in. So now heading back into K3S, we're going to go back to the workloads, and I'm going to go into the pods, and then I'm going to go into the LAPI, and I'm going to execute shell, and I'm going to do a CS CLI decisions, add -i, and then my IP address 192.168.7.100, and add that one. So now that's added. Let's see if Pi-hole is now no longer available. So just to show, there we go. Not available, but to everything else on my network, it is available. And if I change my IP now, I should be able to have access to that. So I can delete that rule now and hopefully get back straight into it. So back on here, if we just do a delete for this rule, that's now deleted, and hopefully I should be able to go back to Pi-hole and just hit reload, and yeah, there we go. I'm back and I'm in. So there we go. This is how you set up CrowdSec. Unfortunately, it's not working on RKE2 at the moment for banning the correct IP address. That's definitely possible, and I will try my best and quickest to figure that out. But as you can see, I've demonstrated this working on K3S. So for those of you on K3S, you'll be pleased to know that your traffic is now secured with CrowdSec. So unfortunately, this video wasn't quite as successful as I was hoping it to be, but hey, this home labbing, I'm just some guy on the internet who's learning this stuff like you are. But at least you can have this up and running on K3S and possibly other distributions of Kubernetes. As I mentioned, I will keep working on this. I have reached out to RKE2 to see what is happening with the network security policies or the CIS hardening that's not making this work. As I've said before, both K3S and RKE2 are done by a rancher owned by SUSE, so there's definitely something there that can be tweaked to make this work. So hopefully for all of you with K3S, you can now get CrowdSec up and running and you can secure your proxy from external attacks. For everyone else running RKE2, we just have to wait and see what happens. But if you did like this video, please give it a thumbs up, please hit that subscribe button, and I'll see you on the next one. Take care, everybody.